Hello there. About 9 years ago, I produced a rather noobish and simultaneously insecure and rather disastrously designed piece of software known as fast encryption. It was an attempt by a much younger version of myself with minimal understanding of the core concepts to throw together what was a high-performance piece of file encryption software as one of my first attempts at a real software project. Of course, a great many things since then have transpired. I've gone through and studied a lot more software and learned a great many things, which returns me to the underlying question of high-performance file encryption. And of course, the answer to that question is actually pretty simple. Frankly, I completely retconned fast encryption and removed the publicly available code that I'd produced many years ago from circulation altogether. The reason for this is pretty simple. The original version of fast encryption that I wrote all those years ago was, effectively speaking, a bit of a compromise in its design, but also as well a fundamental attempt on my part to take what was limited programming skills and apply them to a project that was simply beyond my capability at the time, and that was from the very beginning an extraordinary stretch beyond my limits. Of course, over the years that came, with the advent of AI and with a willingness to try new things as my studies came to a close, I've thrown together a prototype that I believe is a much better, much faster successor to what was then a relatively crummy and disastrous piece of software. That, of course, being the current version of fast encryption, which was developed in 2024. Now, this has been put on the back burner, but this is currently a functional prototype that I use for many different purposes. And of course, being a prototype, it is far from optimized, it is far from final, and it is ultimately more, if anything, a proof of concept. This is a project that I'll be working on, but I figured I might as well demonstrate it. Here we have a file that's 3.6 gigs, and here we have the command to execute fast encryption. We press enter, and we define the number of cores. In this case, we're using a Ryzen 2600 processor at Zen+, so we have access to 6 cores and 12 threads. We will use all 12 of them. Our password will be 1234, and of course, with this version of fast encryption, it supports single file mode, meaning that, effectively speaking, we can encrypt a file in place. This is somewhat inherently dangerous, and I'm not exactly certain if it can be fully compensated for. However, let's just do it. As you can see here, we have an output of the key and IV. This is for debugging purposes only. The first part of the encryption cycle is to, of course, run an integrity check and store those hashes into what is effectively a bin file, felog.bin. And then the encryption cycle begins, and after the encryption cycle finishes, the log file is deleted. The result is that we can very quickly encrypt and decrypt files of just about any size really quite quickly. Now, the dynamic allocation system that's built into this piece of software allows us to do this even on big little systems because of the fact that the allocation is truly dynamic. It's not simply an example of C++'s threading functionality. This took a considerable amount of trial and error and can still yet be further optimized such that the loading across cores is yet even better. And, well, there's also the opportunity to potentially implement a cipher that is a tad faster. But that is in fact a prototype of the new version of fast encryption, which has been in demand by a great many people. Of course, with this particular version, it is far from complete and still requires a lot of refinement and a lot of fixes. That's all, ladies and gentlemen. Goodbye.